Jai Jayendra, Namaste and welcome to my channel. Today we are going to solve the 54th question of the problem solving series and the second question of the heap data structure. The difficulty level for this question is medium and this question has been asked in multiple companies like VMware, Amazon, Flipkart, Citrix, Microsoft, etc. And this question was asked to me in my first interview for Amazon three years before. Okay, so let's discuss. Merge case sorted arrays. So we are given a vector of vector, that means 2D array, and the inner array is sorted, and there are k sorted arrays, right? So the number of total arrays are k, and the outer size of the array is k, and the inside it could be any number of elements. It could be equal to k or 4. We don't care, right? But the number of lists inside this 2D is k. So we need to merge them and return a single array which is sorted. Okay, so let's look at this example. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this 1, 2, 3, this is sorted. Okay, so whatever is the thing, we need to include all of them together and we need to return a single array which is completely sorted. So here we are given k is 3, there are 3 lists, right? 1, 2, 3. So the answer would be simply a sorted array which comprises of all these elements. Okay, so how do we solve this? Directly you will think about sorting, right? So we'll take this vector of vector and we'll add all the elements of this 2D array in a single 1D array, and then we will sort them. So what will happen? So how many elements are there total? Like whatever it would be the number of elements. Say in this case, like there are k here. The size is also like size of the single array is also same, k only. Okay, so in that case there is k square elements, and we know the time complexity for sorting is n log n. So in this case it would be k square log k square, right? Since there are k square number of elements. But how do we optimize this? So since it is a 2D array, we need to traverse it like order of n square times. In this case, since there are k sorted arrays and the number of elements in each array is k in this example, so we'll be traversing it k square time. We can't help it. We have to traverse it that much. But can we optimize this log part instead of log k square, right? What can we do? We know heap priority queue. It gives the topmost, the max. Heap gives us the maximum element of array in order of log n, right? Log the number of elements that are there in the list. Okay, so that helps us to give it. So if we add all these elements to a priority queue, which is a mean heap priority queue, then we extract all the elements and add it to a new array and then return it. Then what would be the time complexity? Will the time complexity reduce? So once we are we have added all the elements to the priority queue. Okay, and then the priority queue will heapify it automatically. It will form a heap in order of n, order of k square, whatever is the traversal of the elements in the array. But then when we are taking the top element of the priority queue, the heap, it will take it and then it will again heapify in log k. So log k into order of k square. So k square log k. So that would be our time complexity when we used, since we have k square number of elements and we have this number of elements in the priority queue as k, okay, in the heap. So this would be the time complexity, right? So since we are traversing it, the number of elements are k square and this is the log k. So this will help us to get the whole list in the single priority queue. Okay. So let's code this. It's very simple. So we take a priority queue. Okay, the mean heap, right? Int. This is the syntax of mean heap in C++ STL. Greater int. Okay, PQ. You can check the syntax, and then we traverse this for I equal to 0 to k, and then for j is equal to 0 to num size dot size. Actually, it's not compulsory that the size of the array is also k, right? So when we are traversing it, we are adding all the elements to the priority queue, array of nums of ij. So once all the elements are added, now we have this, and we have our answer as vector of int answer. Okay, and what we do, we have a single list now in the priority queue which contains around k into some elements, and then we just traverse this list for I equal to 0. So we have int n is equal to priority queue dot size, and then for I equal to 0 to n, and what do we do? Since it's a main heap, we have answer dot push back. We push the topmost element of the priority queue into the heap because that will be the smallest since it's a main heap, and then we pop it out. Okay, and then we return our answer. Fine. So this answer will have the k sorted arrays merged. Okay, the arrays will be merged, and the array would be a sorted array of k sorted arrays, already sorted arrays. I hope the explanation is clear, and the link to the question has been given in the description. Please try it yourself and then down to my code walkthrough section. Here is the code walkthrough of the 54th question and the second question of heap data structure, merge k sorted arrays in the Gigs for Gigs platform. You can see this example which we have discussed, and you can see the companies that has asked this question. So let's look at the solution. That's what we have coded here. Okay, so same as what we have discussed, and we are returning the answer vector that comprises of all the k sorted arrays that are merged and they are sorted. So we will directly submit this solution. So all the test cases have passed, and I hope the explanation, the code, everything is clear. Okay, so see you all soon in the next video where I'll be explaining the 55th question of the problem solving series and third question of heap data structure. Jai Janendra.